Hey everybody, today we're integrating products of sines and cosines. We're going to do 4 problems, but there are really only 2 big ideas. We'll just do 2 examples of each. Let's start with the integral of cosine to the 6x times sine x dx. This one's just a u substitution problem. If we let u equal cosine x, we're going to get home very quickly. Differentiate both sides, solve for dx. Go back to the original integral, take out cosine of x and replace it with u. Take out dx and replace it with negative du over sine x. And now we're in a situation where the sine x's will cancel. Negative the integral u to the 6th du. This is an elementary antiderivative. U to the 6th becomes 1/7 u to the 7th. Take out the u, replace it with what it's equal to, and we're done. Negative 1/7 cosine to the 7th x plus c. Problem 2. Integrate cosine to the 5th x dx. We're going to use the same idea as before. We'd like to pull out a factor of cosine here, so the integral ends with cosine x dx, and then write everything else in terms of sine. Then u equals sine x is going to get the job done. So first of all, let's pull out that cosine. Now I'm left with an even power of cosine to the 4th of x. The reason that that's okay is because that's cosine squared, and that inside cosine squared can be written as 1 minus sine squared, just using the identity sine squared of x plus cosine squared x equals 1. And now that substitution I mentioned is going to work. U equals sine x is going to get us home. So let's do it. U equals sine x, du dx equals cosine x. Solve it for dx. Now we're ready to substitute in. Take out sine x, put in u. Take out dx, put in du over cosine x. And as we expected, those cosine x's cancel. We FOIL out the 1 minus u squared to get to a place where we have a very simple integral. We get u minus 2/3 u to the 3rd plus 1/5 u to the 5th plus c. Take out the u and replace it with sine x to get our final answer. So the procedure we just did is always going to work when we're integrating a product of sines and cosines where at least one of them has an odd power. For example, if the cosine has an odd power, you pull out one factor of cosine and then use that Pythagorean identity to reduce the remaining even power of cosine, all in terms of sines. And then the u substitution, u equals sine x will get you home. The problem comes in when both exponents are even. In other words, when you don't have an odd exponent to do that with. Here's the simplest possible example of that, the integral of cosine squared of x dx. We need a new approach. The way we're going to do these problems is using the power reducing formulas. It says if you've got a square of a cosine, you can write it in terms of cosine of twice the angle. And if you've got a square of a sine, you can also write it as a cosine of twice the angle. So in this problem, integral of cosine squared x dx, we can write it as the integral of 1 plus cosine 2x over 2 dx. Factor out the 2, the integral of 1 is x, and the integral of cosine 2x is 1/2 sine of 2x. Simplifying that just a tiny bit, remembering to put in our plus c, we get the final answer. So that was the simplest possible problem we could do of this sort. Let's do a harder one. Let's do one where we need to use this identity repeatedly. This comes up quite a bit, actually. Integrate cosine squared of x, sine squared of x dx. So again, there's only even powers of sines and cosines here. So the technique we used in the first 2 problems isn't going to do it. We use the power reducing formulas on both of those even powers. So we're integrating 1 plus cosine 2x over 2 times 1 minus cosine 2x over 2. Now let's simplify a little bit. Take out the factors of 1/2, so that's where the 1/4 is coming from. And then FOIL the 1 plus cosine 2x times 1 minus cosine 2x to get 1 minus cosine squared of 2x. Okay, so in that integral, the first part is simple. The integral of 1 is just x. The integral of cosine squared of 2x is going to require another power reducing identity. So this time, when I apply the power reducing identity, and I'm doubling the angle, this time the inside of the cosine is 4x, because I've doubled 2x. Factor out that 2, anti-differentiate, simplify just a tiny bit to get the final answer. The integral of cosine squared x sine squared of x dx is 1/8 x minus 1/32 sine of 4x plus c.